In continuation to our previous lecture, we move now to joint B, such that at joint B, this is our considerations. At joint B, member BC is connected and the components of member BC is also projected, but not the components of member CE and EF, such that only its horizontal component of member CE and EF has a moment arm distance of 20 feet towards joint B. As shown in this figure, only member EF can do moments towards joint B, and the horizontal component of member CE at joint B, such that the vertical component of member CE has no moment arm distance towards B. Disregard this side of the truss system so as to not do so as for us to not go with repetitive equations or repetitive considerations. With that equations, we solve for member EF, such that the vertical reaction at the hinge support is 900 pounds moving clockwise towards joint B of moment arm distance 15 feet. Then the horizontal component of CE, which is computed as CE times 1 over square root of 2. Its horizontal component moving counterclockwise, that is why it is negative, of 20 feet moment arm distance. So CE times 1 over square root of 2 times 20 feet. Then, lastly, the member EF has a moment arm distance going counterclockwise towards joint B of 20 feet as shown in this equation. So 900 pounds times 15 feet minus CE times 1 over square root of 2 times 20 feet minus EF times 20 feet equals to 0. Then substitute the value of member EF, which we have already solved from the previous recorded lecture. EF is 600 pounds, such that the equation now is 900 pounds times 15 minus CE times 1 over square root of 2 times 20 minus 600 times 20 equal to 0 to put the system in equilibrium. Then lastly, simplify this equation to solve for the value or the force member of member CE, where member CE is now computed as 106.066 pounds acting in tension as shown in the figure. So this is now our final answer. With that, we have already identified all the unknown members considered in this problem: member BC, CE, and EF. And finally, for the last step of method of sections, check answers using method of joints for validity for members BC, CE, and EF. So we've solved that member BC is equivalent having a resultant force member of 711.512 pounds acting in compression. Member CE has an equivalent value of 106.066 pounds acting in tension, and member EF has an equivalent value of 600 pounds acting in tension. So another note to finalize your answers, do the same tabulation from our method of joints, considering again the computation of using only dead load, the computation using only live load, wind load, earthquake load, and many other types of load combination. Then simplify the data that you have computed in the tabulation in a tabulated form, just like the table we've used from method of joints. With that, we continue our lecture on the next video recorded lecture, considering solving complex trusses or what are complex trusses and how are we going to solve such type of trusses. Of course, using method of substitution. So we used member substitution with complex trusses. So see you on the next